Okay, if we're looking at multiplying with exponents, we know that the rule is a to the x times a to the y is equal to a to the x plus y. That's the rule. This kind of number here, this kind of problem is still throwing you guys off. I can't tell you how many people said that the base was 4. So let me just remind you, if you're ever looking at it and you're not sure, just write it out and see what happens, right? So 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2. And 2 to the 3rd is 2 times 2 times 2. So you have all of these little 2's that you can write in exponential form. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. That is 2 to the 9th power. Remember, when we're multiplying or dividing, or really doing anything with exponents, the base does not change, right? So that 2 in this problem, that is the base, so your base remains 2. The only thing that changes is your exponent. All right, this kind of problem is very different from this kind of problem, okay? So this -5 here and this 10 here, they're whole numbers. They're not bases of exponents. The bases in this problem are the variables, okay? So we deal with these whole numbers just like we always have. They don't have exponents next to them. This is just -5 and this is just +10. And we just multiply them because that's what that dot means to do. -5 times a +10 is -50. Now, n to the 2nd power times n to the 8th power, these are bases of exponents, and we know that our base stays the same, so it's still going to be n, and we add our exponents. So 2 and 8 make 10. So your answer there was -50 n to the 10th. All right, last one, we're just going to deal with our whole numbers first, just like we always have. We have -4 times a +2. So far we've got -8. And -8 times a -3 is a +24. Now we get to our x's. Our base will stay the same, and I have x to the 3rd, x to the 2nd, and x to the 5th. And I know that I add my exponents, so 3 plus 2 is 5, and 5 plus 5 is 10. So my answer there was 24x to the 10th power.